that they will not give guarantees that there will not be any emissions of fugitive gases, nor what the volumes would be of them. But there is a second environmental concern, and that is of water usage. Each fracking process requires between 1.2 and 3.5 million gallons of water. This water will have had chemicals, propellants, sand or similar substances put into it, which will keep the fractures open and allow the gas to flow freely. Now, the companies will say it's only a very small percentage. We're talking about 1 or 2% added in total. Now you put 1 or 2% of 3.5 million gallons of water, and you tell me how many gallons of muck they're putting in. It's a good few thousand gallons, not a small amount. And that water has to be extracted from somewhere, and then it has to be cleaned up after use before being discharged back into the water system, probably a river. And frankly, it's very doubtful whether it can be cleaned up properly. The average well will require between 3 and 8 million gallons of water over its lifetime, or between 11,000 and 30,000 cubic litres of water. And these figures are based on the US experience. In Europe, where shale is at a greater depth, the water use will be 1.5 times as much. And so I ask the questions, where will the sheer volume of water required for so many fracks come from? If extracted from underground aquifers, this will lower the water levels dramatically, as it has done in parts of the USA and Australia, denying other users, farmers, other industries, and indeed households of an essential commodity. If extracted from rivers, it will seriously affect their flow, with a knock-on effect to the biodiversity. If taken from reservoirs, it could well affect water drinking supplies and or electrical generating capacity. The sheer volume of water that will be used steadily over a number of years to frack will have an adverse consequence to our water environment. I'll consider carbon capture and storage as a possible technology to combat climate change a little later. I'll now move on to the cost of energy and of particular gas. There have been a number of politicians and others who claim that shale gas and coal bed methane will bring down gas prices. They point to the USA as an example. Whilst opponents to coal bed methane are not allowed to point out other legal jurisdictions for evidence to support their case when discussing some aspects of this industry, health issues in particular, it works the other way around when you wish to discuss the price of gas. Unfortunately, they're not comparing like with like. The US market is a very different one to the United Kingdom and European market. The US market is largely an internal one. There are no other competitors for the gas. They do not export it. There will be in the future because they're having to build special export terminals so that INEOS can import it into this country. They don't actually export it anywhere. So the European market is far more integrated. Indeed, the European market actually extends well beyond Europe. One only has to listen to what's happening in the Ukraine and realise that the European market extends well into Russia. So a Scottish gas producer can sell to a user anywhere within Europe. Therefore, if a company in Germany, Greece or Spain offer a better price to a Scottish gas producer than a company on their doorstep, say in Lanarkshire or Clackmannanshire, they'll sell to the highest bidder. Now, to be fair to the gas producers in this country, they have not predicted that gas prices will go down. Gas producers haven't said it will go down, the politicians have. Shale gas and coal bed methane are only profitable if prices are high. There was a meeting we had in East Stirling, the community councils, and I was at it, and the senior planners were there. And the senior planner was asked a question by one of the lady community councillors from one of the community councils, asking, will the gas prices come down? And the answer was the shortest one I've ever known a planner to give. It consisted of 2 letters, an N and an O linked together. We all sat, the whole meeting sat and waited to see whether he would put a caveat to it. And he didn't, and the chairman had to move on to the next question. Will it be cheap gas? No. Now, there are some technologies that are being touted around as being the answer to the problem caused by burning fossil fuels. And one of those is carbon capture and storage. Some 2 years ago, Scottish Power put in a bid to build a prototype carbon capture and storage plant at their Longannet power station, a part of the British government's efforts to see whether it would work. A couple of million quid, I think, or several million quid were at stake. But the bidding process required them to consult groups of stakeholders, including people from the environmental movement. And I, with a number of others from local Friends of the Earth groups and other environmental pressure groups, were invited to go and meet with Scottish Power representatives. It was a very interesting evening, with robust discussion. And the upshot was that the report we submitted was supportive of their bid for finance from the government to build the prototype carbon capture and storage plant. Now, this caused some consternation in some parts of the environmental movement. Some people virtually accused us of selling out to the power company. But the science for carbon capture and technology is sound. The technology is tried and tested. The science and technology just needed to be linked together and used. Our one reservation, well, we had 2 reservations, the main reservation was on costs. The second reservation was the fact that the coal had to be imported from overseas, where employment rights and employment safety for those mining it are at a very low level. And there'll be a lot more deaths, let alone anything else, to those people digging it out. And we just did wonder whether that would be, should be an issue. And when I raised it with them, if looks could have killed, I wouldn't be standing here this evening. Now, a power station uses about 4% of what it produces, which they say is their parasitic load. It's the electricity used in the plant to boil the kettles, run the coffee machines and the photocopiers, the laptops that put the lights on and all that, just the whole running cost of the place. So at the moment, Longannet, 96% of what they produce goes to the national grid. If they were to put carbon capture and storage onto it, then that parasitic load goes from 4% to 25%. Now, there's only 75% of the electricity generated goes to the grid. Now, they've got 4 generators in that power station, so one of them would only be generating electricity to run the power station. It would add about 30% to the electricity bill for gas produced that way. So if carbon capture and storage was to become a part of our response to climate change, the extra parasitic costs alone would add considerably to the cost of electricity, and that is put into one side for the extra amount that would have to be added to our bills to cover the company's additional capital costs. If we are going to be serious about global warming, seek to slow it down and eventually stop it, and then tackle the results of generations of pollutions since the beginning of the Industrial Revolution, we have to say that the days of cheap energy are over. Any politician, any energy company, any environmentalist that says otherwise is trying to deceive you. There will be some energy sources which are less expensive than others, and some which will be, if adopted, horrendously expensive. I'll now turn briefly to the question of health. This is a very contentious area. The problem with health issues is that they tend to creep up on you silently, and only when they can be seen or detected